Good morning. In this video we're going to do object serialization. So what we're going to do is we're going to make some objects. We're going to make them all lined up in memory, and we're going to save the block of memory out to disk. Then we're going to load that back in and take a look at the results. So to get started, I have a module already started here. It's really simple. It just has the standard console window program. All it does is pop up the console window and you press enter and program's done. It has a main function as the entry point. So what we're going to need to do is we need to make some objects. So I'm going to make my first object here for object serialization. It's going to be serial. And the serial is going to have some instance data. And I'll make a public variable that's going to be a string. And a string is actually a module class object namespace, whatever you want to call it. It's in my runtime, so the compiler will understand this because it's part of the runtime library. And I'm going to name it description. And then I'm going to change the value of description.text to be gluten-free flakes. That'll be our default value for our cereal. Now, the next object I want to make, module class namespace. I don't know what to call them. Let's make some milk for our cereal. And the milk is going to be simple as well. It's going to have some instance data. It's going to have a public string variable named color. I'm going to change the value of color.text to be equal to white. And need to make another one. I'm going to try to make this quicker here. I'm going to make some sugar. And the sugar is going to look just like the milk. Okay, so now we need something to put our objects in. We're going to make another object called a bowl. You know, I just noticed something here. We've made cereal, milk, and sugar in this folder, and the files do not show up. They actually have not been written to disk yet. They're just in memory at this point, so I never did notice that before, but not to worry, it'll work out in the end. So here's our bowl. And our bowl is going to be a little bit more involved. So the bowl will be the object that we save to disk and load back in. The bowl will be the container for the other objects, and it's also going to be what creates the objects in serial. Serialization means to line things up. So let's just do this and see what it looks like. First I'm going to make a public string named color. So our bowl is going to have a color. And then I'm going to make a public serial. There's our serial object. Class, module, namespace, whatever you want to call it. Name is serial. And then I'm going to make a public milk named milk. And make sugar named sugar. Okay, so that will be the object. That's your object serialization right there. They're already lined up just by definition. They're not null pointers like a lot of other compilers do. They're actually bundled into the bowl object as one set of data. So you can think of the bowl object as a container, and these objects are inside the bowl, lined up in order, just like you do like with variables, x, y, z. They're just there in order. There's no pointer to them. All right, so let's make a function called report. And oops. I'm going to copy this out several times because I'll need it. And the report I'm going to be writing some things to screen. So it's going to say I first poured the this one's going to be serial description text. First poured the serial description into the color of the bowl. Then I added some, let's do milk color dot text. Milk and sugar dot color dot text sugar period. And I want this last one to be a right line to make this go to a new line. And then I want a blank line, so I do have a module called constants that just has static data in it, static string buffers. And there's one called character return line feed, and that's not nice. There's a glitch. Now let's go over to serialization screen and let's work on this a little bit here. So let's make, this is our main entry point. Let's make some local instance data. which means it's instance data that can only be used by this function, and it's declared down here. But it's still instance data for the serialization module. A new bowl. And then I'm going to do an invoke new bowl dot report. Oh, there's something should not be red. Okay, so for some reason it's making that line, those characters red. So I must have, local instance data bowl, name new bowl. Let's try that. Okay, that's better. All right, let's see what we got here. I first poured the gluten-free flakes into the bowl. There's two spaces there. Then I added some white milk and white sugar. All right, let's go back here. Looks like I did two spaces on purpose. We'll go with that. All right. So now let's go on to. Actually, before we go here, let's go back to the bowl. We're gonna try to save and load the bowl. So we need a load function, and we need to pass a parameter, which is a file name object, and that's also in my runtime. And we need a function called save. We're going to pass that a file name object called my file name. Get a space there. So there's our load and save functions. Now, I have another module class object namespace that will help us do this work, so we don't have to do Windows API calls on a video. I'm going to make a new object here. It's going to be a void object. It's going to be static data. The reason I want to make it static data is because anything that's in the instance data will be saved to disk. And I kind of don't want the void object to be saved to disk. I want it to be separate. So when I make it static, that means that it's not like every single bowl object made will be able to access this same variable. It's like not unique, or I should say it is unique. No, not unique. Anyway, there's not multiple versions of it. There's just one variable in memory. That's why it's maybe called static. So it's going to be a public void. I'm going to call it mvoid. So the m tells me that it's private. Now, let's do the save first. Now, I'll do the bottom line first. So invoke mvoid.code write to file, and my file name dot typed the wrong thing. No wonder. My file name has a path and name. That's a string, so that's .text. So there's an example where the fingers aren't doing what the IntelliSense wants me to do, and it kind of helps correct me there. So the thing about the void is that if you don't give it a memory block, it's going to create its own. So we're going to give it a memory block. So its memory block is in another little object called block, and that has, it's called a reference. And the reference is actually a pointer to memory. And this is pointer support. I have address pointed at. So what is the address of our object would be the next question. Well, the thing about how this object-oriented programming works, one of the key secrets is that when you have instance data, the module, the functions change and they get a hidden first parameter that some compilers call this, but this parameter, or this compiler calls it me. So, and me is essentially the memory address of the instance data of the current object that's coming through the function. And that little trick right there is kind of one of the big secrets to how object-oriented programming works, is that me variable is getting passed in there, secretly passed in every function in those modules or classes. Now the next thing you need to define a memory block is how big it is, not just where it is, but how big it is. So we need the mvoid block dot size. That's going to be the next thing we need. So how big is the instance data of the bowl? Well, that requires some compiler support on the bowl module or namespace. So the bowl actually has code data, enums, and instance data. Well, we're going to be looking into the static data of the bowl because the compiler made some static data for us. So you see that there's the mvoid, what we made. There's also something called module. That's compiler made for every module that you create. And within that is kind of a nice collection. It's a user-defined type of collection of variables that are quite helpful. So we're going to go into the module variables, and we're looking for is the instance data. And the instance data has, let's get this out of my way a little bit here. Oops, lost my drop down. Instance data has some variables as well. And what we're looking for is size of. Okay. Now, that's going to be this reference, this address, and size gets set every time this save function runs. So therefore it's not going, and also the load function is going to get the same two things. So that's my way of making sure that this works, so that multiple bowls can share the mvoid object, because it just resets its information every time. So what we have left to do here for the load is load from file, and it wants this DW with properties named path and name. That's kind of my UTF string, UTF-16 string. And my string object is UTF-16, by the way. And there we go. So there's the bowl, can now load and save itself. Now we're going to go back to serialization screen. This is our entry point. And we're going to make another variable. And we'll stick it on the instance data bowl named brown bowl. So this will be our bowl that we save out to disk. We're gonna invoke brown bowl dot color dot new. This is where we change the color of the bowl. And we're gonna call it dark brown. We can't have a brown bowl without making the bowl actually brown. And now we're going to change some other defaults, like the milk color. Color. We're going to make that chocolate. Chocolate milk in our cereal. And the brown bowl sugar. Let's make that brownish sugar. And then the most important part is the cereal itself. I'm going to change description to be Count Chocula. Now, finally, at the end, we're going to save the brown bowl with a variable that does not exist yet. Well, let's go make that variable then. We'll go ahead and make it an instance data. I'm going to make a file name object named my file name. Now, we need to get the current working directory to make our file name. We want the file to save in the same working directory as the exe, just for simplicity. So I do have some support for that. I have an object called command line, and you have to do an init on it, and it's not actually that big of an object. It just runs a Windows API call called get command line, and then it from there it removes the double quotes, converts it to UTF-16, splits it into path and name. So that init does all that for us, and but we do need to take my file name and change it a little bit. So we have 3 functions to initialize with. So we're going to use the path and name, the path only. That's where we use the command line. Now, the command line doesn't have any instance data. It's static data object. So, and it's going to be text. And text is actually a file name. I should have called it file name. Text makes it sound like it's text. Anyway, I can fix that. Not for this video. Text is actually a file name, and it has path. Sorry for the confusion. I just made the command line object just before making this video, so it's pretty new. Let's do the file name. By the way, let's put the IntelliSense back up. Now we're going to use this function, and we're on the file name and extension. Brown bowl. That's cereal. Okay, so that defines our file name. That saves it out. This is the report of new bowl. So now we have brownbowl.serial saved to disk. So what I'm going to do is I'm going to take new bowl and load in my file name, which is the contents, the properties of brown bowl. So new bowl will get all overwritten with what's on the disk. And then we're going to invoke new bowl.report. Hope that makes sense. Basically, just save it out and load it back in as a new variable. Let's take a look and see what this looks like. Ooh, we have errors. Oh, great. Okay. My error message could be formatted a little better here, I see. .text.path is not compatible with... Alright, so it doesn't like my parameter. I think it's because path is a string variable, and it wants a DW with properties, which is what the .text is. Alright, let's try this again. Well compiled. I first poured the gluten-free flakes into the bowl, then I added some white milk and sugar. I first poured the Count Chocula into the dark brown bowl. There's my double space I couldn't find. Then I added some chocolate milk and brownish sugar. So you can see we reported new bowl twice, and it was different the second time. It loaded in different content. Well, that's all I have for today. It's object serialization. The serializing happens right here when you declare it in the bowl. These objects are not null pointers. You don't have to do new. You don't have to go to the memory manager and get memory for them. They're actually all built in program space, and they're all serialized at compile time already, which made this a lot easier to do. That's why it was so easy. And then you just take the chunk of memory and save and load it, and that's it. So thank you for watching. Hope you enjoyed it.